गाइज, वेलकम बैक टू माय चैनल सक्सेस इंजीनियरिंग ऑफिशियल। आज हम देखेंगे पंप हेड कैलकुलेशन और चिल वाटर सिस्टम, हाउ टू द पंप हेड कैलकुलेशन, पंप सिलेक्शन। तो वीडियो स्टार्ट करने से पहले आपसे रिक्वेस्ट है कि हमारे वीडियो को लाइक करें, शेयर करें, कमेंट करें और हमारे चैनल को सब्सक्राइब करके बेल आइकन को दबा लें ताकि अगली आने वाली वीडियो का नोटिफिकेशन आपको मिल सके। तो आप देख सकते हैं मैंने अपने लास्ट ट्यूटोरियल में इस सिंपल राइजर डायग्राम है, इसका पाइपिंग चिल वाटर पाइपिंग डिज़ाइन किया था। तो अभी हम लोग इसका पंप हेड डिज़ाइन करेंगे। ये पंप सिलेक्शन है, ये पंप कैसे करते हैं, तो पंप का सिलेक्शन करेंगे। तो आप देख सकते हैं ये एक एक्सेल शीट है, दिस पंप हेड कैलकुलेशन फॉर पाइपिंग एग्जाम्पल। दिस इज द पाइपिंग एग्जाम्पल. We made layout just for example to make chill water pipe design and pump head calculation. तो देख सकते हैं प्रेशर ड्रॉप इन पाइप्स एंड फिटिंग हम लोग कैलकुलेट करना है। एंड रेड कलर इज यूजर इनपुट। देख सकते हैं दिस इज द सीरियल नंबर एंड दिस इज द पाइप साइज इन mm, फ्लो इन GPM एंड दिस यहाँ पे ऑलरेडी फार्मूला शेड है, तो डू नॉट टच दिस। एंड ऑल्सो वेलोसिटी इन फीट पर सेकेंड इज ऑल्सो there is a formula. If you see here in this formula, and pipe length is in feet and fittings fitting types. There are different types of fittings and equivalent length of the fittings, and then we will get here total equivalent length of the fittings. Then pressure drops in 5 feet of water is here. Pressure drop in feet per 100 feet of pipe length. For 100 feet 3.317, so 21.9 feet में how much will be the pressure drop? So for 100 feet 3.37, so 21 feet 21 into 3.37 divided by 100. Pressure drop in fittings, feet of water is. So for this much of fitting, this is the length. So for 100 feet total length is 264, so for 100 feet 3.317, so multiply and divided by 100, the total pressure drop. Add these two. Similarly, we have to calculate for the each section like this. For each section this pressure drop in pipe and fittings, and total finally we add here. You can see this all pressure drop added here. Pressure drop in pipes and fittings, then pressure drop in equipment, for example this chiller, AHU and pump. So actually this is given by the supplier. Machine selection is done by supplier. So this pressure drop in the chiller will be given by manufacturer or supplier, and AHU also and pump. Add these two also. Pressure drop in the equipment is 22.4, then total pressure drop for the pipes and equipment including is 73.72, then 10% safety factor 7.73. Add these two, then you will get 81.10. Finally the pump is selected at 1440 GPM at 82 feet of head. So HP is equal to GPM into head into a specific gravity of water divided by 3960 into percentage efficiency, so we will get 42.60 HP. So how to do that? Let's start now. What we will do, what I am doing, I am just deleting this and we will enter again. Okay, so serial number A to V. Serial number A to V, I start from this point A up to here V. A to V, the total GPM is 1440. What you will do here, pipe size already we have calculated in our last tutorial. If you have still not seen that videos, so I will give the link for that video in this description of description box of this video. So we'll go and watch that how to design the pipe size. So you can see here this 8 inch is convert into mm. So what you will do, simply 8 into multiply into 25. 1 inch means 25 mm होता है, so 200. Pipe size is 200. Okay, then GPM is 1440. Pipe length in feet. So from A to B, what will be the pipe size? So just measure with the DI command. DI, click on this point, then type M for multiple up to here. You can see here this 6.5 meter. 6.5 meter convert into feet, so 6.5 into 1 meter with 3.28 feet, so 21.32 feet. 21.32. Okay. And then fitting types, you can see here there are so many types of fittings for this chilled water suction line. This flexible connection, DRV, then isolation valve. So flexible connection, one number. So for flexible we are considering the 2 feet, and there is DRV, then isolation valve. DRV is nothing but the globe valve 1 number. Gate valve, isolation valve is nothing but the gate valve 1 number. And then one elbow, you can see here one elbow 90 degree and one T. Okay, elbow is one, elbow 90 degree, 1 number, then T, 1 number. So for flexible connection, this equivalent length is 2 feet, and for these fittings we have to check in carrier handbook. You can see here this carrier handbook for the pipe design. I will check here. This is carrier handbook. You can see here this chapter on pipe design general, and this is Carrier Air Conditioning Company. Okay, so this table number 10, valve losses in equivalent feet of pipe. So if you see here, this is the nominal pipe or tube size in inches, and this is the pipe size in inches, and this is the fittings. You can see here this is the globe valve, sustainer, and this is angle valve, and this is gate valve, check valve, then white type sustainer, then check lift valve. Okay, so this is the equivalent length actually. This is the pipe size. So how to find it? So first one we need globe valve. So you can see here this globe valve, and the size is 8 inch. So this is the 8 inch, and this is globe valve. So equivalent length will be 220. Okay. So here you simply type 220. Then gate valve. For the 8 inch gate valve, you can see here. This is the gate valve. You can see this is the gate valve. This parallel to this line, you can see this equivalent length is 9. So simply type here 9 and elbow 90 degree. So for the fittings you have to go to this table number 11, fitting losses. So 90 degree elbow, 8 inches here and this is 20. Okay, equivalent length for the 90 degree elbow is 20 feet. And T is this one, actually this no reduction, so this is the straight T. Okay, for a straight through flow, this is a straight through and this is the branch. So actually this how we will define, how we know this is a straight or branch, because this is the flow is going down, because this critical path is this one. So always pressure head pump head calculation is calculated for the critical path. So this is the critical path. So your flow is coming from the top and going down, that's why this is called a straight T. Okay, if flow is coming and going to this side, then this is called bend T. If you see here, flow through branch, now we need a straight T. So for a straight T, 8 inch, this is the 8 inch size, and if you go parallel to similar to this, you will find here 18 feet. Okay, so simply type it here 18. Now add this all these fittings. So if you see here, I am double click here. You see all this fitting length is added. Pressure drop in pipe. So total pressure drop in pipe is here. If you see D11 into 8 F11. So this is the D11. So pressure drop for 100 feet is 3.37. So 21 feet 3.37 into 21.32 divided by 100. So I am getting 0.27. In the fitting also, the fitting length is 269. So simply multiply here 269 into 0.37 divided by 100. So add simply these two, so I am getting here. Now next is B2C. If you see here, B2C is only 1 T. So the pipe size is 150. If you see, B2C the pipe size is 6 inch and GPM is 840. So B2C pipe size is 150 and GPM is 840. And the pipe length is 12.75. So simply check here DI B2C. DI B2C. DLI B2C 3.82 meter. What I will do, convert into feet. So 3.82 into 3.28, 12.5. So 12.5 feet. Okay, the fitting is straight T. What I will do, T1 number, simply copy here and put it, paste here. So T1 number. Now this is for the 6 inch. So the 6 inch the equivalent length will be 14. Here 10. Okay, no reduction, straight T10 for 6 inch. It will be 10. As the pipe size decreases, then this equivalent length also will be vary. Similarly, I am adding here, and then for this 12.5 meter, 12.5 feet, this is the pressure drop, and this is for the fitting pressure drop, and total is here. So next is C to D. simply deleting here. So next is a C to D. If you see here, a C to D. C to D distance 3.8, again 12.5 feet, and 1 L only, because this T is already considered. So C to D, I consider up to here this T and this T, and here is 1 L only. So C to D, this pipe size is how much? 4 inch, and GPM is 360. 4 inch is nothing but 100 mm, and 360 is the GPM, and this is the 12.5 again feet, and one elbow is 90-degree elbow. So simply copy and paste it here. Okay, but this pipe size is 4 inch, so we have to check the equivalent length for the 4 inch elbow. So 4 inch elbow is 10. So simply paste it here, 10. Okay, and this is added all, and this is the equivalent length of pipes for 12.5 feet, and this is for the fittings, and again added here. And now for D to E, you see here D to E. So D to E is what I will do, simply DLI, check the length, D to E 2.36. So D to E, what I will do, simply deleting this D to E 3.26, 3.6, 2. This pipe size is, what will be the pipe size? D2E, and D2E is nothing but this pipe size will be the 4 inch only. So 4 inch, and GPM is 360. D2E, so 4 inch is 100, and GPM is 360. And pipe length. Pipe length, simply check DLI from here up to here, 2.36. So 2.4 meter. Simply convert into feet. So 2.4 into 3.28, 7.8 feet. So 8 feet, 8 feet. And the fitting type is, if you see here, this butterfly valve is nothing but the gate valve and strainer, gate valve, strainer, and flexible connection. So 4 inch gate valve, 4 inch gate valve, one number. Four-inch flexible connection, flexible, one number, and strainer, 4 inch strainer. So 4 inch strainer, one number. Okay, so 4 inch strainer, one number. So 4 inch gate valve, you have to check here, 4 inch here. So 4 inch, and this is the gate valve, so it will be 4.5. Here is 4.5 feet, and flexible connection is 2 feet, and a strainer. For a strainer, this is Y type strainer. If you see, 4 inch is 60. 60 here. Okay, so this will be the addition for this equivalent length of the fitting, and this is the pressure drop in the pipe. 8 feet pipe, 8 into 7 divided by 100, and this is the pressure drop in the fittings, and this is the summation of these two. Okay, and then F to G. Next is F to G. So if you see here F to G, this pipe size is 125. 5 inch actually this pipe size, so here is also 5 inch, so 125, so GPM is 360, and so the gate valve for 5 inch is here 6, and the strainer is 80, so here will be 6 and strainer is 80. Okay, so F to G, flexible connection, and that gate valve, elbow, glow valve, then T. If you see here this F to G, there is flexible connection, then gate valve, elbow, then 1T is here. So flexible connection 2 and gate valve is one number, so 6 feet. Here is 6, and for elbow 90 degree is 125, 5 inch elbow. If you see here this 5 inch elbow 90 degree is 13, so here is 13, and glow valve is 140, one number, so 4 inch glow valve, 5 inch glow valve 140 is 140, and T 8.04, so 8.04. Okay, so this is the summation, and again same this for 8 feet, and this will be the pressure drop for the fittings, and this is the addition of these two. Then G to H. G to H we have to calculate similarly again. This from G to H is 1T only. So if you see here this G to H is 104 inch pipe size, GPM is 360, and this is the 11 feet, and 1T only, so 6.7. So here will be the summation. And this is for the equivalent length of the pipes for 11 feet, and this is for the fittings. Okay, and then again next is H to I. If you see here H to I is 1T only, so H to I 156 inch pipe size, 840 GPM, 1T 10 feet. And then I to J. You see here this I to J, this is the pump section. So in the pump section there will be one elbow, then gate valve, strainer, flexible, then this is the fittings actually. This I to J, this one T, one elbow, and one T branch, one number. T branch one number, then gate valve one number, strainer, flexible. Again K to L. If you see here, this next is this pump discharge line to chiller suction line, K to L. If you see here, this is one elbow, one flexible, one NRV, one DRV, one gate valve. So many fittings are there. So simply type here one T, elbow, glow valve, gate valve, NRV, then flexible. NRV is nothing but the check valve. So for the check valve 200, you will check here This 8-inch check well, swing check well. If you see here, swing check well is 80. So if you see K to L, this K to L is one elbow, and one elbow here. Actually, I am putting here all T, so I am not put here length. Elbow 1, glove valve, so 220, and gate valve is 9 feet, and nerve is 80. Adding these all, and this is the pressure drop for 18 feet pipe length, and this is the pressure drop for the fittings and total addition. Similarly, this pressure drop in pipes and fittings, this total pressure drop I am added here. You can see all value added, and then pressure drop in the equipment. So pressure drop in the chiller is 14.4. This is given by supplier, and AHU is considering 5. Pump is 3. So this is the pressure drop in the equipment, 22.4, and this will be the total pressure drop pipe, fittings and equipment. So I added these two. I am getting 70.08. 10% safety factor is 7, so I added these two, 77.08. So pump is selected at for pump selection is actually GPM and feet is head loss is required. So pump is selected at 1440 GPM at 82 feet head. Okay, not 82 feet, 77 feet. Here is pump is selected at 1440 GPM and head will be 77. The total HP GPM into head divided by specific gravity of water into efficiency factor. Efficiency is 65 to 70% is considered. So your GPM, for example, here your GPM is 1440 into a specific gravity of water is 1 into head is 77 divided by 3960 into 0.07, 70%, so 19.6 HP. GPM 1440, so GPM 1440 into 77, 110880. What I'm here, 110880, 110880 divided by 3960, so 3960 into 0.65, 2574. Simply divide this divided by this, getting 43 HP. Convert into kilowatt, simply multiply into 0.746. So total HP is 42.6 HP and 31.78 kilowatt. So I hope कि हमारा वीडियो आपको अच्छा लगा होगा, तो प्लीज़ हमारे वीडियो को लाइक करें, शेयर करें, कमेंट करें और हमारे चैनल को सब्सक्राइब करके बेल आइकन को दबा लें ताकि अगली आने वाली वीडियो का नोटिफिकेशन आपको मिल सके. So thank you for watching my video. Thank you. Bye bye.